Okay, so I've done this problem in several webinars, and I think a lot of the students have found it quite laughable. So it says a random sample of 40 adults with no kids have a mean daily leisure time of 5.9 hours. Okay, so 40 adults with no kids was 4.91, 5.91. 5.91 hours of leisure time per day. Standard deviation of 2.41. Okay, so we're getting the results of some kind of sample. 40 adults with kids have a mean leisure time of 4.25 hours. 40 with kids and a standard deviation of 1.82. This is where a lot of my previous sections have found funny. I assume that a lot of you do have kids under the age of 18. I don't know how many of you have 4.25 free hours a day. So that's, I thought that was pretty interesting numbers to show in a problem like this. So 90% confidence interval. Let's go to our favorite StatCrunch. Okay. Okay, I'll use the numbers I wrote down here. So these are two independent samples because the first adult who has no kids and the first adult here who has kids, there's no reason to believe that they have any relationship to each other. Okay, so there are two independent samples. So it's T statistics because it's with the mean. Two sample. With data means we have the 40 individual measurements. We don't. It's with summary because we already know the mean and standard deviation. Okay, so the first one, we have a sample mean of 5.91 with a standard deviation of 2.41 and 40 adults. So I wrote the numbers down on my PowerPoint scratch paper. I'm just copying straight from the MyStatLab problem. Mean of 5.91, standard deviation of 2.41, 40 adults. The second one, mean of 4.25. All of you who have 4.25 have plenty more time to spend on your statistics homework, I guess. Standard deviation, sample size of 40. Okay, construct and interpret a 90% confidence interval. Okay, should we or should we not have pool variances? Uncheck. This is actually one case where if we were doing it a second course in statistics, we would look at this and find that pool actually is the right way to go. But in our course, we always go unpooled. So unpooled, confidence interval, 90%. Okay, compute. And here's the confidence interval. Okay, so 2 decimal places, all we have to do is type in the numbers. The lower one for 90% confidence is 0.86. And the upper one is 2.46. So for those of you who saw that this interval did not include 0, you are correct. If we were doing a alpha equals 0.1 level hypothesis test, that would correspond to the 90% confidence interval, and it would be a reject, okay, because 0 is not inside the interval. Check our answer, and that's good.